Now it's time to make our third and final graph. Just like last time, Control C to copy your time data points, Control V into a new column. This time we're going to graph these times versus the inverse of the concentration values. That's 1 over the N2O5 concentration. Again, we can have Sheet do the work for us by typing equals 1 divided by, and then just click the number you want it to take the inverse of. So I'll click my 2.08 cell and hit enter. You can have it automatically take the inverse of these other data points by clicking on that cell, Control C to copy, click the square in the bottom right hand corner and drag it down, and it automatically took the inverse of these 4 concentrations for you. Now we can make the exact same graph one last time by highlighting Insert Chart. So again, it gave me this scatter plot automatically. That's good. Under Customize and Series, we add the linear trend line, show the R-squared value, and add the equation for the line. Now that you've got all 3 graphs made, it's time to use them and make some analyses based on what you see. The whole point is, out of the 3 graphs, to pick the line that is the straightest. And in this case, my natural log graph with an R-squared of 1 tells me that these 4 data points are the straightest of the 3 lines. Anytime the natural log graph is the straightest of all 3, that means that your reaction is first order. Another thing that this tells you, the slope of this line, 0.0375, will be the value of the rate constant K. So I also know with this data that K equals 0.0375. And if you're lucky, since this reaction only has one reactant, I can also write the rate law for the reaction, which is going to be rate equals K, following our standard format. K is times the concentration of the N2O5, and I know the exponent of N2O5 is going to be 1 because the reaction is first order, and as the only reactant in the reaction, the N2O5 has to have that exponent of 1.